Hi guys, how are you today? I hope everything is fine. I haven't seen you for a long time because I've been busy. But today I'm going to show you how to analyze the Mtcars by using a linear regression from simple to multiple regression. This video is requested from my friend in YouTube, so I will do it for him and for you. And let's do it! Okay, today we're doing the Mtcars as our data, and we will analyze these Mtcars using linear regressions by using R. Okay, let's go to R. So do you know this clock now? I have to go to File and Text File, and then you will save that. Okay, you can save that to here. Let's say Mtcars. Mtcars.rmd. Okay, and then do you know this Mtcars is built-in data in R? So let's check where is this Mtcars house. So if you click that Mtcar data, okay, and you can find the Mtcars here. Oh, okay, you can control F if you can't find anything. Control F. What does it get? Working Control F here. Okay, so let's go back my RMD. Delete that one. Let's copy this running here. Next, we're going to check the state now. Mtcars. What is this inside in here? So that is it. So there are 11 columns and 32 rows. My concern is this is the brand name. This one, the Mazda that song is not included in the column. So my trick is you will save it to your drive. Okay, let's save it to your drive. Okay, but before saving that, we will we will install the packages. So just copy that I have before. Okay, so you have to install the packages here. So I already installed the packages, so I just put that hashtag. Okay, just save time. And then next we are going to save that in your drive. So you can set, so let's say export to drive as CSV. Okay, so what we are going to do is we have to set the TIR for that. And then we get what is this? My copy here. You have to give the F. So I'm going to save it here in my public documents. Okay. Don't forget to change this into forward slash because are using the Windows. So if you're using another or Superior's that Mr. Okay. Okay, then we will just copy this one. While right by right. You have to copy that Mtcars, right? And where did you save that? Is it dir? Then code is mtcars.csv. Perfect. Okay. Now it's already saved in your. We'll check it in here. Okay. And the next one, you are going to open that to your file. Let's say open to open this empty or CSV, because my concern is because at the end we were going to put the brand name and brand ID. Okay. Okay, how to open that? So we will call that Mtcars. That is Mtcars. We call the new names now. Data. Then you have to read the file read, and then use your face 0 dir, comma the Mtcars. That's CSV. Perfect. Okay, let's see if it is opening now. Okay, so we will check the structures. I'll check the structures of the Mtcars data. So then we're going to check the summary. Okay, Mtcars data. So this is it. This is the structure. So the MPG, the miles per hour. So I'm going to check to my. Okay, is that you have to check the variable. This is the MPG, the miles per hour, the CWL, the number of cylinders. And I haven't clue what is cylinders. I asked my husband last night. Okay, then displacement, and I haven't clue what this one. The horsepower, I know this is a little bit, I know. Then the RT rehearsals, the weight. Okay, the weight of the car. Automatic, I have a manual because I live in Europe. No, most of cars are manual here. Okay, that's it. So next, what we are going to do. Okay, let's check, play around with this one. So I'll check the dimensions. So sticker. Oh, I don't know the walking speed now. So you can check the dimension from the Mtcars. What is that now? And then right. Okay, so that's one 32. The dimension is it's just column and rows. So we have y column 32 columns 32 columns and 11 rows. So columns is the y-axis and the rows is the x-axis. So as you can see it here, also here. Okay, so that makes sense. Okay, the Mtcars date. Okay, that's the thing I did now. And then how about if we're row 1 to 5? Select rows 1 to 5. So what you going, because we could do we have a data table. So what you're going to do is select rows from 1 to what is the rows. So as you can see it here, these I will show you about. That's what I hated. This mask, that thing, or the brand name is not included, but I will teach you later on. So there's nothing there. Okay, so how about if you select columns. Okay, so it's Mtcars data. So that's the I. You have to put, what's that name? Comma. To select, let's say MPG. Oh, what is it right now? I want to put that I because we're going to multiple columns. MPGCYL displacement. What else? Okay. And you can learn a bit more later. Right. Okay. So we just select that 3 columns. That's the way. So what is next? Okay. So next one, we have the gear. Okay. Let's talk about gear later. So the manual transition, this is 0 for the automatic and 1 for the manual. As you can see it here. Did I say it? Right. And this one also is B for 0 for, I think, 0 for B shape. And this is the engine one. That's the engine one. Okay. And 1 for the straight. So I'm not in the car, so I haven't a clue what is this. Okay. So let's go back to R. So we're going to select. So let's say select. Don't forget to this curly thing. LC course. Select it. Where the EM equals to 1. Okay. What's that? Did I say that? Oh, that's right. Okay. Then put a comma because this is in rows. Okay. So it's selected all. Okay, next one is 5 columns. I already tell you that. Okay, this is interesting because where is that now? You can check also the head. The head. You have 32 columns here. 32 rows. But if you select the head, it displays only 6 rows, so it saves you time. Or if you have a 1000 rows, so it saves time. So if you want to select the bottom head, what's the opposite of the head? Is the bottom. Head and tail. So the head and bottom, the bottom. Okay. Yeah, and the right. Okay. Perfect. Okay. What next? Let's say quantile of the Mtcars data. Okay, I will select the weight of the car. Is row Y because I got the thing. Okay. So this is the quantile. quantile of the weight. Next, we'll just select if you have selected the quantile, so select the variance. So select the variance of the weight. It takes time, so variance is so we can select this Mtcars date. Select the weight. Perfect. Okay, this is the variance 0.9. What if you will select the histogram? The histogram of the horsepower. And what is that? Histogram. ST display of the Mtcars date, and then comma and HV. Okay, that's it. Density. Gosh, let's talk about plot the density. But the density Mtcars data density of the weight. Okay. But if we create a table by group or group by gear, create a table of the gear. So let's add Mtcars data and create a table by gear. Okay. So this is a table, it doesn't make sense. I'm confused. That's awful. So that's the way I love this. So if we would mix different things, to select the Mtcars the N, and then go to buy gear. That's nice. Okay. Did you understand this one? How could be horizontal, but I think this is better. This one. I haven't clue what this is. That one is confusing. This one have the name. Yeah. Okay. That's done. The pie table. The pie. That is the table. Mtcars data. Select the gear of the pie. Side okay. That's okay. Right. Okay, the pie is okay. Bar plot of the gear. Okay, let's say the bar plot. Bar plot of that. Next table. What am I gonna say? My copy. Mtcars data. Okay, then. Are you still sleepy? Okay. Okay, that's the bar plot for the gear. Which doesn't make sense at all. If you will not put the name. We'll do that later. Where is that now? Correlations. Correlation is the relationship between the two variables. Sometimes. Okay, we are going to select the MPG. What is the correlation? Displacement and weight. Why? Because I did not put this. again. That is mistake. MC, okay. Why again? Okay. What is the problem with that one? Okay, so because I select the Mtcars and I did not put this point. Okay, the correlations of all that Mtcars. So don't be wrong today. And then this is 11. Oh, perfect. So how to read this one? So of course the correlation of the MPG is 1, because there's a relationship between the two. This is the correlation between the MPG and CYL is negative 0.85. So there is a negative relationship between the MPG, doesn't matter, and then also the displacement, negative relationship, and the horsepower. But there is a positive relationship with the DRT, negative relationship where all this one. And the gear is also positive, 15 positive for the transmissions. The engine 0.66. It's positive direction, positive direction. 0.66 the correlation. It's closer because it's above 0.5. Let's try a bit better. There's this one. QQ norm. What's next? Where is Z? Because it's hard. QQ norm for the mouse where are. Okay, then got that one. QQ line. Mtcars data for. Okay, do you put the line? The MPG. Okay. You put the color. What is red? Renal fire. Furious. What did you see? To me, this is outliners. It is strict. The line is okay. We are looking at that these points are closer to the line. Something wrong with that? MC card. What you're looking here? If the MPG is greater than 10.4. Right. Okay. So you select the NBG that is equal to 0.4. So how about what's that? I could not distort that. About this Mtcars that is greater than that MPG that is greater than 10. Okay, select this MPG that is greater than 10. Right, that is. This is now. Let's say 14. Let's say 20. That's the outliners, I think that 10. So you cannot, that's why here you cannot see what kind of car. Who is it better? But in the research, we will not show them because that is illegal. That's privacy. So we will be doing this simple regression. Simple regression. So next we want our outcome. Outcome is the y-axis and the predictor your x-axis. So we want to see, but we want to have the, what is your hypothesis if your outcome variable MPG and your predictor it's just only to the transmission, the manual, the let's say the manual and the automatic. So okay, just remove that order. That first. So what was it to investigate? What we're investigating? What did they say here? If the transmission automatic it is equals to 0 and manual which is equal to 1 is significant predictor. Predictor of MPG miles per hour. So you can say is automatic or manual is good for the miles per hour on the fuel. So I'm interested in this one because I have a manual car. So I want to know which is better. So you can set your HO. HO is the null hypothesis. So we can say there is no significant difference between MPG and EM. So your alternative hypothesis, which is H1, so there is, you say, there is a significance difference between MPG and EM. That's perfect. Okay. I'll just check the box plot. The box plot. So this is a trick again. That's my video. So because you can download this from the RStudio. Okay, the box plot. Right, this is the box plot here. Because I'm doing the x, the discrete variable and the continuous variable. The MPG is our continuous variable, and the discrete is the EM, which is 1 and 0. Okay. So the box plot first, we go qqplot. Okay, we have the Mtcars or data is Mtcars. Data. You have ES. And then you put the X. So I should not tell you this first. So as factor. Because if you will not, okay, we'll see that. Okay, we'll sure that we will come back to that. Okay, then the Y is the MPG plus you add this geometric box plot. Geometric box plot. Does it say that you will add something that okay? That one. Just you start with ggplot. Okay, so we are in a hurry and we are in lazy. So that's the way it is. Right, because that EM is a continuous variable, but that is not. That is a categorical in SPSS. We'll put as factor. Now it will change. Oh, see, that is 0 for the automatic and the manual. So there is when you use the ggplot or a boxplot, so you can see the difference between the manual and automatic. So it's higher. Yeah. What is that now? Okay, there's a histogram. So histogram for that Mtcars with chicken or so you can see my chicken here. So it looks distributed. Oh, my stomach is hungry. So we will check this Shapiro. Oh, it wasn't working. What is this one? Insert or okay, you go to the Shapiro test. So you will see here. So next is Mtcars data, and then go to EPG. So see, it looks like the when you check and the Shapiro boy. The p-value is 0.12. So if you plotting the figures, the MPG and the boy figures, okay. Total, okay. Here we got MPG. Yeah, this and pointed comma. Got the data. This MPG. Oh no. Mtcars data. Okay. Okay, that's the pairs. I'm not gonna explain you that. It's like a okay. So if we will do the t.test, then t.test MPG we have okay. How many? Okay, data. That's wrong. Okay, that's wrong. That is right now. Yeah. So there's a significant bit difference between the two because the p-value is less than 0.05. Okay. The p is 0.0013, which is less than the p-value of 0.05. Okay. So there's a significant difference. As you can see, the mean in manual is 24 and the mean of the automatic is 17. So which is the manual is higher. There's a significant difference between the two. Okay, we'll do the linear regression now. Okay. Simple linear regression. This LIN regression. So linear regression mean and MPG, which is our y, and this, I don't know what's the name of that. That is the x, y and x, right? And then our data. What is the name of our data? The data name is Mtcars. Okay, then will not be working. We will not check the summary because we are lazy. We just check up the summary. That's all what we need in it. Regression. So as you can see it here. So this is the residual that you check the normal, if it is normal distributed. So that's why it is normal distributed. As we will check using the spaces, the mean is equal to 0. That's what we're looking for. Do you want to see that? Okay, then the residuals, that's okay. The intercept, see the coefficient that the intercept, the mean of the group 0 or the automatic, and then when you compare to automatic and the manual, this is the result. This is 17 minus 24.4. That is 7 something. So the difference between the automatic and the manual, as you can see also in here, the box plot. There's a box plot here. So the difference between that one is 7.4. The mean. Okay, right. And you can see it also in here. There's a significance difference. Transmissions is a significance predictor to the miles per gallon, the fuel. And as you can see also it here, the F statistics. This is a significance that the model, there is significance. There's only one model. The model is significance. So but there's always a but. There is only 35 or 36% contributed the MPG. Okay, so we'll see it here. So this is our hypothesis to investigate if this transmission is better predictor of the MPG. Okay, yes, that's fine. I already told you that. This is the goal for the, and then this is the residual. It looks for the mean. And then this is the residual here. Looks like it's normally distributed because of the minimum and the maximum. That's the y. Your y is MPG and x is your transmission. So we are looking for that line. This is the regression line, and the b1 is the slope, is the b0 is the intercept. So this is the formula that you are looking for. So this is the same, right, to make it clearer. So the value of b, the change in y with the unit change in x. So this is the e is the residual, which represents the difference between the score predicted by the line for the subject and the score actually achieved by the subject, or the subject in here is the brand name or the brand ID. Okay, the coefficient that we are looking for, I told you that this is 17.14 for the automatic, then it's compared to the manual, so the 7.2. So that's it. And next, this is the spaces one. I don't need that one. Okay, but that one comes in estimate tells about the model, if it is significance, their significance, and is statistics text, the t1. If it is different from 0, I simply added to the further. Okay, we are looking for the significance value. Okay, the t values, that's one. And there are only 35%. 36% of the variance in miles per gallon is explained by the manual. So we're looking for above the f-test of the f-value. So if the model significantly explains the variance in the y outcome, that's it. This is for the in the species. So that's the one thing here. Again, and then. Okay, so I will go back to this later on. Okay. What else? Let's see the MPG mean, right? By the mean the MPG. So if you create a new column, you can put like that, but I don't need to. I just put it by EM. Okay. By EM, so we'll check that one. This is the product. So we learn by doing. This is wrong, so we learn that. Okay, that's it. The mean. So if you will put the order for that, order the EM. Put negative, decreasing. Okay, I can put the yeah. So that's it. 17. Okay, you know the secret. We will check the regression between the MPG and the gear. So same story. Where I am now. Okay. So what we called it? What did I call this regression? Regression 2. And we have the data LM. We want to check the MPG and the gear. Okay, and the data is Mtcars data. And I will check the summary. Oh, I hope that is okay. Regression 2. This is very fussy. I'm blind, but you can see. Okay, that's four gears. So this is integers. Remember that they are integers. So because it doesn't make sense here, it's hard to interpret that one. Oh. Okay, regression. It doesn't copy that to save time. But save the time. And then this one will put the integer as factor. Close. Okay. 42, 43, 43%. A little bit. This is significance. The model is significance, and you can see it here that this is the intercept for the gear. How many gear is it? 3. Let's get. Wait a second. Get the order it one. Let's order the gear. So this is the gear 3. Significance. Gear 4 additional for the gear 4. What's the difference between this? Is that one okay? And that one for the gear 5. There's significance. Small significance. It's only 43%. Okay, well, we'll check the mean for that. We will confirm that to, where is that now? Mtcars data. And then we have to go to, no, not that one, because it will add to the, I said the MPG. Oh, don't forget this. Close parenthesis to mean of the MPG by year. And it's sure no, this one. Why? What's wrong? Okay. To the order so that you will not confuse. So the last time, what did you do? This is the mean. So what we did the last time, this is the count, this is the mean, this is the count, and we're looking the mean. As you can see, there's a difference between that. Where is that now? That this one, n, the count of the year, which is n, and y in the y or x, y, g. That's it. We're calculating the mean. So this is the 16. As you can see, there is 16. And the difference between 16 and 24, that's 8.4. And the difference between 16 and 21, that is 5.27. Okay. What did I say? The cylinder regression 3. The MPG, the LM. MPG, where is that? Between the, it is, now we'll put a factor, okay, because you are integer originally. Factor of the CYL, the cylinder number of cylinder. That is our data. Our data is the Mtcars. And then don't forget to put the summary of the linear regression 3. Okay. Alright. So what did you say? Oh, okay. We're talking 73%. Number of cylinders in your car is 73%. So 73% of the miles per hour is explained by the cylinder. Okay, so if we're going to check the mean of that, okay, don't forget this one. Always MPG mean, just the mean for the MPG by, okay, let's see, by cylinder. Check the order of the number. Okay, so as you can see it here, this is the mean, the cylinder 4, right? That's the trick. And the difference between 4 and 6, that is 6 minus. Then the difference between cylinder 4 and cylinder 8 is negative 11.6. Well, this makes sense. So now we learn What did I say? Do the carburetors. Is that okay? I'll do that for you. So linear regressions. Now what we will do is for the 4. I do you know that one. The next one is the MPG. Did I have the clue what is this carb? Carb BB. Your data is the Mtcars. Data, okay, then don't forget the summary one. Chicken with chicken. Regression 4. Okay. What did you say? Oh, this is awful. This is only 30%. 30% of the miles per hour is explained by this carb. I don't know what is carb. I do the research, not mine. Okay, so you can do also the interaction. So let's say what's the interaction between the horsepower and the transmission interaction. So let's see what did about regression. Regression. I will check my dismail now. Linear regression between MPG and it's the h-bit interaction between the factor as factor. So data, so where did we not MPG? So Mtcars data. Don't ever forget the summary. This linear regression with what 4? 5, this is 5. Okay. Right, it's working now. That's why it is. So what did you see? The factor between the EM. I think this factor between the I think this is mediation, not moderation. Moderation. Okay, but for the factor there is no significance between that one. There is no significance if you include the factor between the HP, horsepower, and the transmission. So doesn't matter. There's no significance. You can leave it out. It doesn't make sense at all. But my worry is why there is this 78% contributed by that factor. And there's significance here. It doesn't make sense. There's no significance as well. But just leave it out. We'll do the next lessons for the mediation and moderation. Next, okay. There you go. So let's go back to cylinder, number of cylinders. So as you can see, the number of cylinder before this one is integers, but I want to add the dummy variables. Did I have dummy variables in here? Okay. So my dummy variables. Okay, that's the one there. Okay, this is the dummy variables. As you can see it here. Where is that? Oh. Yeah, anyway, that is, I want to make a dummy variable. So if I will compare between the CYL, should be CYL 4 versus CYL 6, and should be like that. But to save time, or to save versus CYL. So if you will put the CYL 6 into 1 and the rest are 0, then if you select the CYL versus CYL 4, you put it into 1 and the rest are 0. So we're going to add dummy variables. For the CYL. Okay. So how are we gonna do that? Where's my, I got to shoot Mtcars data. CYL 8. Is it 8? 6. 6 first, we go to 6. Then if you add another columns, you can use that command. So as integers, you don't have to use that. Okay, if else CYL, you are using this 6 walls. So basically we had changed, we add the CYL. Okay, CYL 6 will change into, why did I say 2? This time 6, then else 1 and 0. So I told you here that if we were going to 6, you go to 1 and the rest are 0. Okay, you know that crap now, right? And if you want to go to this faster now, CYL 8. New variables, as integer. Okay, that's wrong. So you will learn how to use if else or now. CYL and dummy variables 8. Which is 1, the 8 become 1, the rest are 0. Okay. You don't have to be. So if we will check the Mtcars now. Is it right spelling? It's very sensitive now. Okay, that's the thing that it's added now the CYL as a dummy variables. That's a dummy variable, CYL. Let's say linear regression. Regression number 6. 6 now. 5. This then. MPG. CYL6 plus CYL8. Here you don't need to put 4 because it's your baseline. 4 is your baseline. Okay. Right, the same thing, is it? 26 MPG. Okay. So we checked it again if you want to check it again. Equals the mean for that. What did I say before? PG linear. So I just want to show you how this is similar here. Right. The mean for the 4 is 26. So the difference between 4 and 6 is minus 6.9, and the difference between 4 and 8 is 11.6. So 73% accounted for the cylinders, the same story that we've done before. So we're doing the multiple regressions. Multiple regression. So basically, how to say, did I have something in here? Okay, maybe not there later on. So okay, we have to delete the CYL first, so that we can do this thing. Mtcars. You know how to delete the command in data.table? How to delete the column 6. So if you declare to delete that one, put that now command, and then the mtcars data. And we go doing the CYL8. So put that then null. Right. So it's gonna. You can check if you want. So we'll do multiple regression. Multiple. So let's say linear. What did it say? Multi. This is a multi regression. Now what between the MPG as this one and all. The point is all. You see the least. I don't know, that's kind of English thing. Okay, that's it. Okay, don't forget to okay, the summary. Does it won't work? guess you will post below. Okay. Are you joking? I think there's something wrong with this computer now. No, there's not something wrong with the computer. There's something wrong with my eyes. Okay, that is right now. It doesn't make sense. There is no significance. Non-significance. So what we will be doing? Go home. Okay, if we were doing the backward step, there's also a hierarchical step, but we'll do the backward. Regression. So step backward. Don't get it too further. Called stepped. Multi. The one that we have that in before. And just put so that you will not be in trouble. Have the direction. That's what we call it backward. Forward. So you will not trace means you will not the trace means you will not copy all that stuff. So don't go with the summary. Multi-regression. Backward, not the other one. Fingers crossed. Okay, this makes sense. So now it says that there are 85% contributed to the model. So our predictor are the weight, the Q is the, I don't know what is that, the DEM, the transmission. So there are significance here. So you can see that this is the intercept. How to read the intercept? It says that because it's the intercept for the add automatic plus the weight and the QCA when they are when the X are 0. Did I have something in here? I don't think so. Okay, right. That's the one. Okay, let's go back to it in R. So I'll talk about that later. So summary backward QCM. So the residual standards is 2.4, which is lesser than the previous one, and the coefficient of 2.9 is the expected change in the change in MPG when you compare with the automatic and the manual in the presence of these two variables, weight and QSIC. So can we get this residual plot? Residual plot is to see if it is normal. What is this residual plot? This is normality distribution. So this bar, this is bar improve W 2 by 2. That's 2 by 2 to do. Okay. Oh, whoa, we did that. So if you messed up, just put this. Okay, that's the thing. Oh, I have to plot. Oh, this is on high. Regression backward. So we're going to plot that one. Oh, come on. What did you see? Residual fitted. What it said? It says this one is supported the independence, the assumptions of independence, and the qqplots. That one. It seems this one, this plot that the point is closer to the line, so that's what we are looking for. So it means it's normal, and the scaled location is the confirms the constant variance assumption, and the last one is the leverage residual. So this said there is an outliner since all the points between the 0.5 lines. The residual was also concludes that there are outliers. There are outlines. I told you there are outliers. So the manual said the manual is better than the automatic. So it say the manual is better than the automatic because this is the manual here. And then, but we can compare that. We can reduce it. We can. I'll tell you that later. And yeah, that's all. Okay. So just for the correct. So if we just select Mtcars. Okay. If we're looking at MPG, so that was before it's greater than 22.6. So we select the column, the MPG column, the EM column, the QC column, and we select the order by MPG. Okay, right here is the. This is not that one. It should be like that. Wait. No, they will not do that. Because it will change. Yeah, so we select the MPG that is greater than 22.6. This is the AM, the QC. Okay. That's the one. So if you want to order to descending, just from here, 9 rows. Okay. So now we want to transform we transform the CYL, the gear, and the curve. What else? EM. using the BS also to factor. So how we will do that? Because these are all the CYL gear carbo, I don't know the transmission. They are in how to say categorical. So we have to transform that in R. We have to transform that and to factor. So but before anything else, so that we will not store this one, we will make a copy of that Mtcars data. So we'll create a copy so it will not destroy the other one. So you have a copy now. So we have to Mtcars data 2 and 2 convert this. What is it? CYL first. And when you change CYL, look at the carbon in this one. Why? Mtcars 2. Let's see. What hexagon gear? Is that gear? Yeah. The last one. So we're good to go now. You can put label too. Okay, I can see that the BS, the EM are in factor now. CYL. Okay. Next, what we're going to plot is the violent one. Violent, where's Where's the byline here? This one. Did you see that one? This. Okay, that's the one. Create the byline plot qqplot. It's a qqplot. Yeah, what else? Your data is Mtcars. Data to Mtcars data to select that one there. Yes. Your X is EM. Your Y is MPG. You don't need to put a box there, it's already changed. And then we need to add this geom byline. I don't know who created this one. I need byline. Oh god. So the X is, we'll say the X is the transformation. Right. And you will add the transformation to 0 for automatic and 1 for the manual. And when you get to the Y, we call this Y the miles. Let's see, per column, the amount of miles. Okay. Plus T. Doesn't like that name. The name. What is wrong? So what's wrong with that? Before I put this code in here, it should be somewhere here because there's only one X here. Okay. What did you see? You see there's a big, this one, concentration. We're looking at here. So you see there's a significant increase in miles per car per carbon, the manual translation, that automatic. The shape of the distribution extremely wide in the middle, so it's in feet. Suggests that the miles per hour for automatic transmissions are highly concentrated in the median, the middle, and around the first quartile for the manual. So it's concentrated in here, the middle, and the first quartile in the manual. So we're going to plot it to, we'll try to plot the MPG, the weight, and the PS or the engine. So another plotting here. There are two continuous variables. So remember the plot the MPG. These are two continuous variables, the weight and the PS. So going to copy is so smooth. So it's pain and does now. So ggplot. Just copy that one. Mtcars 2. The area is the same. imaging, and we have the color, so we will put the color, wait, the color is equals to dbs, the engine, to then just put G on smooth. Then we don't label that now. A plus the G on point is a built-in one there. P. Okay. Then put the label. Lobes. And we say the X. So don't we confuse this one? X we have to wait, and then use excerpted code. Y is the put code. Miles per column. Yeah, the color is the engine. The color. This is you have 0 equals to V, and 1 equals to straight engine. Okay. Save the outside. Not in the inside. Because we will be in trouble. What is wrong with you, Jim? It's my chicken. Come on. Why you did not get... Okay. So this is the color here. I got here. It's smooth. Okay, what do we say? So the graph shows the relationship is linear with one outliner. Where's the outliner? Is that? That one. Could be that one too. Go to the data table. Check that, check. Mtcars. Mtcars 2. You have to get the. We'll see the B is 1. Then select the HP. So we selected. You select the B. It's the one. Mtcars data. Oh no, we'll check the simple regression between, because it is already transformed. I want you to see how it looks like. You either it transforms your regression. Let's say what is the one? Have MPG and that one to EM. So we don't need to put a factor because we already transformed that. Mtcars data 2. In summary, Okay, again. So now it is level now at 1, so 1 is the manual one. Okay, then next we'll do the multi-regressions of all. So we will check the all regressions. So what it is a multi-regression? To all each year, then comma data, which is Mtcars data 2. Then don't forget to go to summary. So hungry. Okay, this is nothing, makes sense. So we will do the backward. So where's that now? Step backward. Got the step. What did I say? Multi-regression. Regression. Backward. And you do the same thing. We have to trace it to 0. Okay, summary for that is t.table. Okay. Oh, yeah. If you put it through, it will say everything here. So step 1, the start the IC, then 9. Okay. So yeah, you are looking for this one. Where are we looking the 2? So we remove that one. Let's say false or 0. To read it easy. Okay. So now this, we could say the contribution of this 4 variables is 87%, and they are significance. Okay, I think so. The model has 4 predictors: the cylinder, the horsepower, the weight, and the transmission, or the miles per hour. The R squared value is 0.87. That the model explains 87% of the variance in miles per hour. The coefficient is shows the increasing number of cylinder from 4 to 6, with a decrease the MPG by 3.03. So the cylinder compared to cylinder 4 and 6, so it's compared, there is a decrease in MPG by 2.16. So if you increase the horsepower, it will decrease the MPG by 3.2 for every 1000 horsepower. The weight decreased by 2.5 horsepower per every 1000 pounds. So I have something, it is for, so before, that's one. So we, okay, multiple regression by the backward step. Okay, well, let's explain that. So this is the formula. It's the intercept 3.9 minus 1.2 decreasing. So that's before, when we did not change the EM and BEC or cylinder into factor. So that's the difference. So what is the, by using that one, so we're looking for the expected value of the MPG. So we could say, okay, where I am now. So that's the one I'm showing you, that one. I beg, what's wrong back? So what is the change in cylinders? Change in cylinders, gear, BC engine, the transmission to factor. So this is the result for that, which is this one. And then, so that is the intercept showed the average improvement in MPG of the automatic cars as personal horsepower is 0, which doesn't make sense. So from 4 to 600 MPG decreases by 3.03, from 4 to 8 cylinders decreases by 2.1, and HP increases by 1 unit, MPG by 0.32 horsepower. So the weight increases by 1 unit, and the MPG by 2. Okay, so what is the expected improvement in MPG when HP is 1110, the weight is 2.2, and the manual is the MPG and the HP is like that. Okay, with the HP is 1110 and the weight is 2.1, and this manual, then 8 cylinder. So first thing first, we will check the, wait a second, I'll show you how to get this one. Mtcars data. Looking for the MPG, BSVM here. Oh, no. It's just MPG, CYL, horsepower, weight, and EM. That's what we're looking for. So yeah, that's the one. So we're looking for, we have to do the math between do the math for the HP with the horsepower is 0.32. So you do the math for your HP, the rest are constant. So for example, so when HP is minus when the HP, when the horsepower is 110, so what is the mpg? So if the HP, if we increase the HP for 245, so what is the mpg? So the mpg here is 23.3, so it will reduce, it will increase and then it will reduce. So if you reduce the HP, which is 110, and if you increase the HP, let's go to the opposite. If you reduce it, the mpg, the mpg will increase. If you increase the HP, the mpg will reduce. So how about for the weight? For the weight, let's comparison with that. If the weight is 2.6, which is lesser than 3.57, so it goes the opposite then. Do you know what I mean? If you increase the weight of your car, it will reduce the miles per hour. So my car is, very small weight. If you reduce the weight of the car, so it will improve the miles per the fuel. Okay, you just consume a small amount of fuel. So if you have a big car, you consume the greater amount of fuel, but the speed will change then. Okay, so this is my sexy favorite car, Ferrari. Damn, gosh, I don't know when I can buy it. I already explained you the multiple regressions in different ways. So make it sure to change it to factor if it is categorical, because it will affect the analysis in every analysis. That's why you have to do data cleaning first. Okay, what I promised you in the beginning, that we have to put a brand column. Okay, we have to create new brand, but that is illegal. What I mean, not acceptable in research. If you put the ID and the name of the person that you are researching to. Okay, so we will check. Why is not here? Create a brand name. So if you create a brand name, if you create a new column, put that. Okay. This is painful. Mazda RBX4. That's it. And then the other one, the same thing. So Mazda. Just imagine that you will. So the trick is you have to put in X in Word or a notepad, then you just copy and paste. So there you go. This is created the brand name, and then I have to check that it is created. Just add it in here now. You can create also the brand ID. Let's see here. So Mtcars data2, which is 1 AC. What is that? Brand ID. So don't forget that 1 to 32. So you created the brand ID name 1 to 32. Okay, something is wrong. Why? 1. Again. So it's already there. So priority, I'm looking at the priority. No, if I look at the priority, what is that? Mtcars data2, which is common. Brand. What is brand name? It's equals to Ferrari Tino. Oh, okay, where's the Ferrari Tino there? So I'm looking at the brand name so that it comes to place. You can use that. Next, I'm looking the MPG, demands parabola. Next is cylinder. Next the HP. Next is the weight. Oh, that is it. 19.7 cylinder. Then it's manual because it's very old, but it's still sexy. So, but this data, doesn't include Mtcars. I'll show you that. This data doesn't include the experience of the driver, the age of the driver, the skill of the driver, the gender of the driver. What else? Personality of the driver. What else you're looking for? Age, gender, personality, the skills, or the occupation of the driver. Or if the driver lives in the city or in the country. What do you think? If the driver lives in the city and the country, most of the city people don't know how to drive because they rely on their transport, and the one in the country are driving. How about the gender? The gender, the female and male. Okay, there's a difference that you will judge. And the personality of the driver. This is a risky driver and the least risky driver. The occupation of the driver. If the driver is working somewhere far away from their home, so there's a difference there. So you will judge, and it's better to have a data like that here. Okay guys, my favorite questions. What codes have you learned so far? What do you think? There's a lot to take on, but it thinks it is easy so far. So bye for now, and thank you for watching, and don't forget to ask. You just ask me what you want me to do, because I'm going to reply it. It will take longer, but I will, and I will do it for you, so that, because if there's somebody will ask me, I keep doing something else and I will not be motivated to do it. So thanks for watching, and see you in my next video, and just ask me. And I think that's all, and bye for now. I'm so